channel Bal Vigyan Bharti. So we are progressing on vector addition. In that we have reached the problem number 32. Sorry, up to problem number 33. So moving to the next, I have started some theory that is on collinearity. If two vectors are collinear, in that the topics that should be discussed, that is the vector linearity, that means they are collinear. So this is the first topic, and opposite that or non-collinear. This is the opposite topic of that. If the condition which satisfy the first one and the opposite condition will satisfy the second one, but condition is that those vectors must be in same plane. Okay, in same plane. Second one is coplanar, or if they are not coplanar. So these are the topics that has to be that has to be discussed. So we have started already the vector linearity. There what are the things? If I take to discuss it, if I take two vectors of kind combination of vectors a2j plus a3k, that means these have three components I, j and k. I am talking about spatial coordinate, means Cartesian system, that is x, z and y. The unit vector is I, j and k in respective directions. These are the unit vectors, and so the total vector, the vector which is a set of vectors like that, having x component, y component, z components. Components are those if vector is being distributed in mutually perpendicular axes, that is the standard one, x, y, z. Cartesian in two dimensional, it is x and y. So if I divide such a way that it is distributed among the two axes or three axes, this must have the components along x, y and z, or x and y if it is a two dimensional. So I am taking another vector, that is b1i, b2j plus b3k. Now the first condition for vector linearity, that any vector, let's say a and b, is the condition is that a is non-zero, b also non-zero vectors. They are not which. The first condition is that. Second condition, they are coplanar. So that means they are in the same plane. Okay, so now that linearity, the first you have to understand the concept. If I take any plane, let's say this is a plane, there may be several vectors in so many directions. Out of that, if some vectors is lying like that, it is following the same straight line, or they are parallel to each other, maybe in opposite direction also, but parallel or collinear. That opposite vectors, if it is a, then opposite vector may be of minus a or a, is also parallel to each other or in collinear. In all such cases, these are follow the linearity rules, so which I am talking about right now. So now a must be related such a way that a and b, if it is non-zero and coplanar vectors, they must be multiplied with a scalar. This is the scalar one. Okay, so this must be related such a way that this relation can be fetched or can be established. So if I take any physical example or practical example of that, let's say I am assuming that a is 2i plus 4j or 3j, let's say, plus 5k, and b is 4i plus 6j plus 10k. So So now from there, if I for B, if I take 2 out, so that means 2 is a scalar, and it can be easily converted into the form of the vector A. So this can be written as 2 into A. So you can see that any vectors, it can be either A multiplied by scalar of the B, or B multiplied with the scalar of B, can be represented in any form. Okay, so now in this case B is equal to 2A, that A is a scalar here, so these two vectors can be said collinear. Okay, this is the first condition. Now if I take the second condition is this: if two vectors is correlated such a way that can be multiplied with a scalar, so then if I multiply this with any scalar this, so in that case when I will expand this will be something like that: a1 a2j plus a3k is equal to lambda b1i plus lambda b2j plus lambda b3k. Now in this case each elements also to be equal, that means a1 has to be b1 and a2 has to be lambda b2 and a3 is equal to lambda b3. Now here you can see that these vectors are non-zero. The condition for any such relation, if it can be represented like that, instead of unit vector there may be any vector x, y or z, any vectors. So in that case also those individual elements should not be non-zero, otherwise this condition will not fulfill to be a collinear. If any is zero vectors, then we cannot say that lines are collinear. Okay, so to satisfy this, there is also a condition that none of the vectors, elemental vectors also zero. It should not be zero. So this is the second condition, and the third condition is that to be a collinear, there are two kind of product or multiplication will do. That is, one is dot, that is a scalar product, and it is cross. So here any two vectors which is multiplying as a dot product can be in the form this. We can establish this relation for the dot product. Here theta is the angle between the vectors A and B. So for dot product, it definitely has to be in the same plane, that vectors and the vectors multiplication is a scalar multiplication. So if this implies, then this will follow the cos theta rule. But here to be a linearity, so in that case A cross product has to be 0. A cross product is nothing but the similar way, but it has to be followed by sin theta. Okay, so if I take any two vector A, B, so if it is theta, so this cross product has to be follow this, and here to be collinearity, this vector will lie on this, that means theta is equal to 0. So that case sin theta is equal to what? Sin 0, that is equal to 0. So to be if the cross product, that means if theta is equal to 0, the ultimately it will be 0. So cross product of that vectors will be 0. That means if I assume ai plus a2j plus a3k, this is one vector cross b1 I plus b2j plus b3k is equal to 0. Now if I do all product, if I multiply, this has to be multiplied one by one to each other. So I into I, the cross product of similar vectors, has to be 0. Why? Because I into I is equal to I mod into the sine angle in between. So sin 0 is equal to 0. So any similar unit vectors when multiplied as a cross product will give you 0, and that of the other one will give you the value 1, because this is followed by a Cartesian. So any cross product, this means vectors this I cross k, if I cross product, the resultant will come in this direction for cross product. Okay, this is a rule that follow the right angle thumb rule. Okay, so just as of now, you don't go to that extent, but you understand if it is a cross product of similar unit vectors is 0, cross product of a different unit vector is 1. So in that case, when you multiply the similar, that will be all nullified. Only the thing that will remain as this into the this, means if I take a1 b2 is ij, a1 b2, let me take in a same order. A1, this one will be 0, then a1 b2 will be there, okay, first, and ij will give you 1, this one, this a1 b3 into ik, I into k will be positive. Now I have to take care of the sign. How it will be? Just follow me. Now this is over. Now next, a2j and b2i. This is j. This direction is j. a2i. What is I am multiplying? J cross I. So j cross I means from there to I am rotating this one. So this will follow this. If I follow this way, so it will follow the positive z direction, means j cross this. If I go this way, so the angle the result will go this way, so this will be positive, a2 b1. Okay, now next to j will be 0, a2 b2 j into k. J into k, that means it is rotating in this direction, so that resultant will be in negative direction, okay, not in the positive direction. When you will rotate this way, that means you are following the anti-clockwise, not the clockwise. So when you move anti-clockwise, anything move this way, if you are rotating this, the screw will move this way. If you rotate this way, this will then, so you have to see the rotation angle, means it is started with j and rotating towards k, so that means your screw will move this way. If we take right hand screw, so this way, that screw is that, so there the sign will be minus a2 b3 will come. So here you have to cautious about the sign when you are doing cross product. For sign product, dot product, it won't be a problem. So then the last one, this is over, a3 k and I. So from k to I, if I move this way, the screw will be positive, and then a3 b1. Now initially what I did, a1 b1 is 0, a1 b2, a1 b2 is I and j. From I am moving, so this way it will be positive, okay. I k means I and k. From I, oh sorry, I and j, no, from I to j, if I move this way, so move, this will come this way now, then it will be what is that, I and j, a1 b2, a1 I and j, I to j, this way I am rotating, this will move down, I to j, it will be minus, sorry, you have to take minus here, I k, I to k, this way, okay, fine. This a2 j, a2 I, j and I, j to I, k positive, j to k, that means I am rotating j, this is negative, j to k, a2 b3 negative, so fine. Then last one, A3 I to K. I to K is positive. So that means A3 B1 will be positive. And last, K to J. K to J, that means I am rotating this way. K to J, this will be K to J, that means I am rotating this way, it will go that side. So then this has to be something minus a K into I, K to I, so that will go this way, sorry, K to I, that means it will be negative, sorry, K to I, that means it will be negative. I am rotating K to I, that means it will loosen up, this will go this side, and this will be positive. When I am moving K to J, that means K to J, that means I'm rotating this way, so this will move up, so that will be A3 B2. So this will be ultimately, I will get like that, B causes when you are doing, so ultimately minus A1 B2 plus A1 B3 plus A2 B1 minus A2 B3 plus, sorry, this will be minus A3 B1 minus A3 B1 and plus B3 B3 A3 B2, sorry, A3 B2. This will be the final figure. Now arranging this all together, this will be A1 B3 minus A1 B3 minus and the relation that I have got, A1 is equal to I assumed B1, A2 is equal to lambda B2 and A3 is equal to lambda B3. Okay, so this will be like that. Now if I replace the value here itself, so A1 B3 means A1 will be replaced, if I replace it, A1 is equal to lambda B1 B2 plus this will be A1 is equal to again lambda B1 B3 plus A2 is equal to lambda B2 B1 minus A2 is equal to lambda B2 B3 minus lambda B3 B1 plus lambda B3 B2. Okay, now if I take lambda all common, lambda, so it will be minus B1 B2 plus B1 B3 plus B2 B1 minus B2 B3 minus B3 B1 and plus B3 B2. If it is that, so B1 B2 will be cancelled out, B1 B3 will be cancelled out, and the B2 B3 will be cancelled out. So ultimately this will be something, what I got, the cross multiplication that I did, A cross B is equal to my lambda into 0, that means it's 0. So that can be proved by the second part of that of collinearity, where I said that each element, that if two vectors are related such a way that it is a multiple, one vector is multiple of scalar vector multiple of other, and from that each element has to be same, that I have told in the second condition of the collinearity. So if I use that, the third condition, that cross product of the vectors is also 0, that can be proved here. So these are the major three condition. So if it has to be collinear, then also it's said to be related such a way that if it is collinear, this condition has to be satisfied. This three condition has to be satisfied. Collinearity also said to be that this has to be linearly dependent. It is same as I said. If it is linear dependent, then the coefficients, that if it is, let's say, one vector is a1 x1 plus a2 x2, it is a vector. If I say, then these are individual vectors which are non-zero and coplanar. Then linear dependency means that if these are the coefficient, the scalars, then a2 has to be 0 and a1 x1 plus a2 x2 also to be 0. So these are the condition. Okay, so here individually that must not be a1 must not be equal to a2. Means any of these two any of these two must not be 0. Means if I take ai representing the a1 and a2, so ay not 0 for at least one case. Means either of one of a1 a2 must not be 0. So this is the condition for the linear dependency. So if it is collinear, so this apart from these three that I have discussed, there has to be linearly dependent. For linear dependency, this is the condition. So this is useful when you will do linear dependency test, because there is another term that is non-collinear. That means they are not linearly same. In non-collinear case, this condition will change into linear independency. Okay, so again, if it is non-collinear, the second part is if non-collinear, then the first condition that I said, A is equal to lambda B, will not satisfy. It should not be like that. That means here lambda is equal to 0 for non-collinear. Okay, for non-collinear, this is the first case. So if it is 0, so then a1 I plus b1 a2 j plus a3k, that I assume has to be 0. Okay, now these are non-zero, so if it has to be 0, then individually that all to be 0. This is the non-collinearity, and this condition is said to be the linear independency. Independency means they are not dependent to each other. So if it is non-collinear, the condition of linear independency like that, this can be generally represented as, if I assume x1, this is another vector a2y or a2x2 you can say, or a3x3 is such vectors. If it is linear non-collinear with b1 x1 plus b2 x2 and b3 x3, so then these vectors said to be, this coefficient individually should not be 0. Means should be 0. Sorry, if it is collinear, the linear dependency is that this individual coefficients has to be 0. Now if this cannot be proven, cannot be presented, so this is multiplied. Means if I put this in condition plus a2 x2 plus a3 x3 is equal to, not equal to lambda, and lambda is equal to 0. So b, if I represented, this is b, this is a ultimately, so b, this will be 0 totally. So in that case, it has to be individually 0 each, because these are considered to be non-zero vectors. Okay, so in that case the coefficient individually has to be 0 to be, this has to be 0. Okay, so in that case also, if I am not considering the unit vectors instead of a general vectors, so in that case also a1 is equal to a2 is equal to a3 is equal to 0. All coefficient, all scalars to be 0. This is the condition of non-collinearity. This is the second condition. And non-collinear means the third condition was that A cross B, for collinearity we have assumed what is A cross, not assumed, we have seen that if it is collinear, then theta is equal to 0. If it is non-collinear, so this value will not be 0. Okay, so that is the another way of cross checking whether the vector is A and B is collinear or not. If it, in case you are not getting the angle between the vectors is not, theta is equal to not 0, so then you can say that this is not the collinear vectors. So this is the one part. And the other term that we have used for collinearity is they are linearly dependent. In this case, for non-collinear, it will be linearly independent. So that I have already discussed. That is to be, means f1 x plus a2 x2 plus a3 x3. If it is, can be represented, this x is a set of vectors, then with the collinearity we can say that this has to be 0. First thing is that I have seen for case of unit vectors, but along with that a1 a2 a3, or if it is more than 3 also, in that case all has to be 0. This is the condition of linear independency, and the same as the collinear non-collinearity. Okay, so these are the case when you will do the example, that will give you more clarity. So in next video I will bring the sum on this, how to prove whether it is collinear or non-collinear. Then after I will move to the planar and non-planar condition, and that will follow by some other topics. There I will calculate the distance between a point to a plane, that with a method of Cartesian vector addition method. And then after what are the topic it is remaining? This is one topic. Another topic that I will discuss, the normal here to build the normal vector on a plane. If it is a plane, there then I will first I will form the equation of a plane, how to fetch that plane, and any normal, how will I get the equation of a normal from the equation on the plane. So those topics will cover, and that will be the end of the vectors. Then it may take another 2-3 classes, and if not much example I have to fetch to understand that, it will be a maximum 4 classes. Then after we will move to the mathematics section, because that is a long pending. I am not moving to that, as because I am continuously I'm progressing on physics subjects, because those are subjects are very related. Then again with some mathematical classes I move into the physics again. So this way the thing will go. So don't lose your hope or lose your interest in that, because both parallelly both the subjects are important, and those are very interesting subjects I am discussing. So thank you for now. In next video I will come with the example to prove whether it is two vectors are collinear or non-collinear. Thank you.